All right, guys, I typed out your notes because I thought this would go a little bit faster. So hopefully you read section 1.7. It's on deductive structure. So the definition of deductive structure is a system of thought in which conclusions are justified by previously assumed or proven statements. Okay, so you're deducing, you're figuring something out using information. It's what detectives do. Okay, they deduce, what's happening. So the proven statements or the previously assumed or proven statements that they are referring to are as follows. So we are going to be using undefined terms, okay? And those are just terms that are difficult to define. For example, a point, a line, those are previously assumed statements, okay? We're going to be using some assumptions. In geometry, we call these assumptions postulates. Okay, so we're referring to assumptions as postulates. And I gave you an example. Postulates are unproven. Sometimes they are reversible. And we're going to talk about reversible down below, so don't worry about that yet. My example is 2 points determine a line. So that's a postulate. It's just obvious, okay? It's nothing that can be proven. You draw 2 points and you connect it and it makes a line. So that's an assumption. So that's a postulate. Next is a definition. Okay, you guys know what a definition is. It states the meaning. And a definition, and this is important, a definition is always reversible. Okay, so this is what I mean when I say it's reversible. If an angle is a straight angle, then it measures 180 degrees. That's my windshield wiper angle. If an angle is a straight angle, then it measures 180 degrees. Let's reverse it. If an angle measures 180 degrees, then it is a straight angle. Okay, that's reversible. Definitions will always be reversible. You can always use, you can switch them and reverse them, and we're going to talk about what that is. And then lastly are theorems and other conclusions. Okay, those can be proven and are often not reversible. So the only theorem that I think you guys heard of before my class is probably Pythagorean's theorem. And we get to do that in chapter, I believe, 9. So we will get to Pythagorean's theorem. But theorems can be proven. So every theorem that we use, we can prove it. And you prove it without using that theorem. So we can use other theorems to prove theorems. And I promise we will get there, okay? So this helps us deduce or figure out problems. We're using assumptions, definitions, theorems, and undefined terms to help us prove things, okay? That's what we're doing with A, B, C, and D. They're just being used to help us prove things, okay? And if you see on my Google Classroom, I left you guys some flashcards on quizzes to help you remember these. The next thing you guys have to know is a conditional statement, and that's just a statement in if-then form. Okay, so my example is, if an angle measures 180 degrees, then it is a straight angle. That is a conditional statement. It's that easy. Okay, but you do have to know parts of the conditional statement. So the part after the if, that is called our hypothesis. I know it's sounding like science. This is called the hypothesis. Okay, and it's after the if. Do not include the if. So if I said, what is the hypothesis? You would say, an angle measures 180 degrees. Okay, that is the hypothesis. After the then, you probably are guessing it right now, that is called the conclusion. Okay, do not include the then. If an angle measures 180 degrees, then it is a straight angle. Okay, this is actually a definition, so that means it's true, okay? And because it's a definition, we know that the converse or the reversal is always going to be true, and we're going to get there, okay? A lot of times how we refer to this is we refer to the hypothesis as the P and the conclusion as the Q. So oftentimes you're going to see something written, if P, then Q. Okay, you can also see it written like this, P, arrow, Q. It means P implies Q. So if that hypothesis happens, then that conclusion will happen. The converse is just the reverse. So if I wanted to write the converse, I would take the blue conclusion and put that for the if part. So the if and the then still stay where they're at. I just flip the blue and the yellow. So if it is a straight angle, and of course I want to put the subject in the hypothesis. So if an angle is a straight angle, okay, so again, you notice that the angle is the subject. Then it measures 180 degrees. So notice what I did here. I talked about the straight angle in the hypothesis, and now the conclusion is it measures 180 degrees. Okay, so I just reversed them. That's called the converse. And what I did there was I took it and I made it if Q, then P. If Q, then P. I usually use the arrows. To me, those just make more sense. And that is what the converse is, okay? Because this was a definition, this is still true. If an angle is a straight angle, it measures 180 degrees. That is still true. And I have some examples down below. Okay, so let's look at example number 1. I am going to highlight the hypothesis in yellow. If an angle measures 90 degrees, that's the hypothesis after the if, then it is right. Okay, so that's my conclusion. If an angle measures 90 degrees, then it is right. That is true. Okay, that is a definition. If I wanted to write the converse, okay, converse means reverse. So instead of P and then Q, I'm going to flip it and put if Q, then P. Okay, if Q, then P. I just like the arrows. So I'm going to write if an angle is right, then it measures 90 degrees. And again, this is the definition, and definitions are always reversible, so this is true. If an angle is a right angle, right, we all know if an angle is a right angle, then it will measure 90 degrees. We know that to be true every single time. Question 2. If Steve got a B on his math quiz, here's my hypothesis. Notice I'm not including the if. Then he passed the quiz. Okay, if Steve got a B on his math quiz, then he passed the quiz. This is a true conditional statement. This is in if-then form, so it's a conditional statement. It is true. The converse or reverse would state if Steve passed the quiz, then he got a B on it. Okay, I flipped them. If Steve passed the quiz, then he got a B on it. Now let's think about that. So if you guys got a quiz back and you passed it, does that always mean that you got a B on it? Nope. This is a false converse statement. Okay, that's all we're doing is we're identifying if it's going to be true or false. Question 3 is not in if-then form. So I first have to write it in if-then form, which is called the conditional statement. So if an animal is a dog, then it has 4 legs. So I just wrote it in if-then form. Okay, so my P part, my hypothesis, is if an animal is a dog, not including the if, and the conclusion, it has 4 legs. Okay, so if an animal is a dog, then it has 4 legs. I mean, I would say this is true 99.9% of the time. It could be false. So even if it is false just one time, we would state that this is false. I'm sure there's been dogs that were born with, 3 legs. So let's go ahead and write the converse or the reverse. If an animal has 4 legs, then it is a dog. And that is false. We know that. There's lots of other animals that have 4 legs. And we know that they are not dogs. For example, a horse. Okay, so that is a false converse statement. If it is Saturday, so this is already in if-then form, the conditional statement is done for us, then I am not going to school. Okay, and again, most of us would probably put true. If you happen to have something at the school on Saturday, you might be going there, so you might state that this is false. The converse of this would state if I am not going to school, then it is Saturday, which we also know to be false because it could be Sunday, or it could be Monday with like a school holiday. Okay, so just making sure you guys understand. These are my 4 examples for it. Making sure you understand a conditional statement is just a statement in if-then form. We call it the hypothesis is the if after the if. The conclusion is after the then. We call it in a P then Q form. So P stands for hypothesis, Q stands for conclusion. Converse is just when you flip them or you reverse it. Converse, reverse, that's how you remember it. And we're going to be working on some deductive structure stuff. So hopefully this clarifies some information on section 1.7, and I will see you guys soon.